To find the angle between two vectors, you use this formula right here. Theta is going to be equal to the inverse cosine of u dot v over the magnitude of u, magnitude of v. If you want to see the proof for that formula, it is on page 133, and you use the law of cosines to derive that formula. In this example, we're going to use the formula to find u dot v with the given information. So looking to find u dot v, we're going to start with the cosine of theta. And theta is given, it's 5 pi over 6, is equal to u dot v, that's what we're solving for, over the magnitude of u, that's 6, times the magnitude of v, which is 8. So now we're just going to simplify this. We know what the cosine of 5 pi over 6 is. We're in the second quadrant. The reference angle is pi over 6. So that's going to give us negative root 3 over 2, since we're in the second, equals u dot v over 48. Again, all we're doing is trying to solve for u dot v. So we'll multiply 48 to the other side. And so u dot v is going to equal, we can go ahead and simplify this. 2 goes into 48 24 times. And that's going to give us negative 24 square root of 3. In example 4, we're going to find angle A. In order to find angle A, the first thing we're going to have to do is find the magnitude of the vector AB and the vector AC. So in order to do that, we're going to have to first put them in component form. So we're going to do vector AB, and we learned this in section 6.3, and we're going to put this vector in component form. To do that, it's x2 minus x1, so this is going to be 4 subtract 3, and then y2 minus y1, 2 subtract 0. Because we care about the direction, when you're putting it in component form, you always start on the terminal side and you subtract the initial side, and that will give you the right direction. So this vector in component form is going to be 1, 2. Now we'll find the length or the magnitude of that vector. So the magnitude of vector AB is going to equal the square root of 1 squared plus 2 squared. This is going to give me the square root of 5. Now we're going to find the component form of vector AC. So looking at this, we're going to do AC, and we're going to do the same thing we did to find the component form of vector AB. We're going to do x2 subtract x1, so 5 subtract 3, and then y2, which is 1, subtract 0. The component form of that vector is going to be 2, 1. You'll see that when we try to find the magnitude of that vector, the magnitude of that vector is going to end up being the same as the other one. So because we're going to have 2 squared plus 1 squared, which is the square root of 5. So the magnitude of both of these vectors is root 5. Now that we know the magnitude, we can come up top and we can use the formula to find the angle in between those two vectors. Now we'll find theta. To find theta, theta is equal to the inverse cosine of u dot v. So that's going to be 2, 1 dot 1, 2 over the magnitude of AB, which is root 5, times the magnitude of AC, which is root 5. It's the magnitude of the two sides that the angle is in between. All right, dot product. So you'll do 2 times 1 plus 1 times 2. So that's going to be 2 plus 2, which is 4. And root 5 times root 5, which is 5. Theta is going to equal the inverse cosine of 4/5. You put that into your calculator, you're in degree mode, and you get 36.870 degrees. That's the angle, theta right here, in between vector AB and AC. Orthogonal vectors. In example 5, we're going to determine if the vectors are orthogonal, parallel, or neither. Orthogonal vectors are two vectors whose dot product is equal to 0, or angle between the two vectors is 90 degrees. Basically, they're perpendicular vectors. Parallel vectors, if you remember at what angle cosine theta is equal to -1 or 1, we know theta would be 0 degrees, 180 degrees, or 360. So if the angle between the two vectors is 0, 180, or 360, we know that the two vectors are parallel. The first thing I do is I test if they're orthogonal by taking the dot product. The dot product is simple, so V dot W is going to be, we're going to take vector V, which is 3i minus 2j. Don't let the i's and j's throw you. Just write it in component form. The horizontal part is 3, and the vertical part is -2. Dot 3, 4. So dot product as a review, you take 3 and you multiply it to 3. You add, you take -2 and you multiply it to 4. That's going to give me 9 subtract 8, which equals 1. Because that is not 0, we know that the vectors are not orthogonal. The next test is the parallel test. In order to determine if it's parallel, we're going to do cosine theta is equal to u dot v. Well, I just did u dot v, that's 1, over the magnitude of u, which is the square root of 5, times the magnitude of w, and that's 5. And this is going to give me 1 over 5 root 5. I am looking for 1 or -1 in order for this to be parallel. The magnitudes I did over here on the right-hand side, just as a review really quickly. How do you find the magnitude in component form? It's basically just Pythagorean. So magnitude is distance, so we're finding the distance of that vector. The square root of 3 squared minus -2 squared, which equals the square root of 9 minus 4, which is square root of 5. And then I also did the magnitude of w. So these two vectors are neither parallel or orthogonal. So you would write neither. All right, let's try one more example. So the next example, again, I always start by doing the dot product first, and that's the orthogonal test. So we're going to take 3, -2, dot 4, 6. Multiply your horizontal components, 3 times 4, plus multiply your vertical components, -2 times 6, and this is going to give us 12 subtract 12, which equals 0. So my first test came up as 0, and that's the test to determine if it's orthogonal. So these two vectors are orthogonal. Not even sure if I'm saying that right. Okay, thanks.